We automate all of your walls, windows, doors, ceilings, everything fully automated from your 2D drawings. And it takes seconds. One of our bigger tests is 50,000 square meters of a building. That takes about 1 minute and 20 seconds.
Hello, and welcome to a new episode of CADTALK. My name is Jörg Lantzsch, and in this podcast we are talking about computer-aided design. From software to hardware, from actual technology to future developments. Today's episode will be once again on BIM. And in the UK, BIM is a very consultancy-oriented business. And that's why we are talking to a consultant today. Ahmed Abdelmagid is founder of AHA Associates in London. It's in London, right? Hello, Ahmed.
Hi, how are you?
I'm fine, thanks. Good that you find the time. And perhaps you're sitting in, it's very international today. We're in Germany. You are located, today you are in Istanbul, Turkey.
Istanbul, correct.
Your company is located in London, but you started your career or your education in Egypt.
Yes.
So tell us a little bit about your personal history.
Sure. Well, after school, I entered university and I was given a couple of choices. And the one that compelled me was I had the choice of either civil engineering or architectural engineering. And the only family member that I have that is an architect is my uncle. The rest are all doctors. So I said, okay, maybe a career in architecture would serve me better. At least I know someone who's done it before. So I got into architectural engineering, which is a very different domain to what the UK has. It's an engineering course where you have the first 2 years as a civil engineer, and then the 3 remaining years are architecture purely. So I did my bachelor's in engineering in Egypt. And then once I was done, I had in my 5th year gone to a course on sustainability in architecture in the UK. And I really liked the way they taught. And I was like, okay, maybe that's where I should head next and see what opportunities could lead there. And I ended up doing another bachelor's in the UK for architectural technology. Now, architectural technology is a bit different than architecture because it's more about the internals of the structure, the material makeup of the structure itself. And that was quite eye-opening. So you'd have a background of civil engineering, and then you then take architecture as in design and then understand how everything works. You're ready to start your career understanding how structures actually function in total. But during that time, BIM was up and coming. So I said, okay, perfect. Let me do my master's as well while I'm here. And as my father says, you decided not to become a doctor to spend 10 years in education. You spend the same 10 years anyway. So I did my master's in project management with a focus on BIM specifically. Yeah, and that was my education career.
So, but you tell me the truth, you moved to London because of the weather, huh? It's much better
Absolutely.
than in Egypt.
Yeah.
Okay. And when you started your professional career as a consultant, I said in the intro, it's very much consultancy. It's heavy on consultancy, this BIM in the UK, right?
Yes, correct. The BIM is heavily allocated. So why you have a lot of consultancies in the UK in general regarding BIM? BIM's history in the UK came along with its mandate in April 2016 or thereabouts. So there was a mandate to come that all projects would then be something called BIM level 2. And it really didn't mandate that you would need any 3D models. And in its early days, it was almost associated always to Revit. And a lot of companies had not been using Revit at this point. A lot of UK companies would have come across Revit, but they would primarily either be working in CAD or MicroStation. And therefore, consultancies try to then partner up with software vendors, do the training for these companies, and then do the implementation for it as well. So you'd have a very consultant-led implementation. Again, because of its early days and because of its, I would say, like, it hadn't grown enough, there wasn't a full understanding of what BIM was would probably end up being, there wasn't a lot of focus on information management, which is the core principle of BIM itself. So BIM as in building, but you have information modeling, which is the core aspect of BIM itself. And that was a lost part. But as again, consultancies dominated that space. And I would say up until today, a lot of clients still heavily rely on consultancies to operate. They outsource that BIM part of a construction program, and that would be essentially consultant led.
I mentioned that you founded your own company. So after a few years, you were bored, or you were enthusiastic to earn more money or to do your project, the projects you like, or whatever?
Well, it's a mixture of a couple. So sometimes you want to move a bit faster than companies that you work at. And that was one of the things that motivated me to move a bit faster. It is much, much harder to open your own company because with a named consultancy, for example, I worked in Symmetry, which is a very big consultancy worldwide in general. You have the benefit of not needing to win clients on your own. There's a full team that does that. Where when you're opening a company, it becomes much, much harder. You're doing this all on your own. You're starting fresh. You need to do the sales, the marketing, the consulting, the implementation. You'll do everything. But it motivated me because I had a very good opportunity with a lot of my career before opening my own company, working at pretty big firms, architecture firms. Worked with AHMM, KPF, Zaha Hadid, Foster's, Grimshaw. So it gave me a very, very good, solid background of what best practice was and how these companies dealt with consultancies in general. And usually these companies are actually opposed to consultancies, but because of the immaturity of BIM at that time, I would say that prompted them to start looking at having training. And then they ended up, most of these companies, creating a dedicated team that lives inside now. And that's the disconnect that happens between firms and clients. Firms end up insourcing this for the long term, whereas clients are usually concerned about one project, usually, or two projects. They don't care to have this as a team long term.
And you started in 2019, I think.
Correct.
And tell a little bit about how a typical project works for you when you start with a new client.
I can tell you multiple versions of this. So some clients I end up doing something very, very specific. So when I started in 2019, I was working in a consultancy at the point, Turner and Townsend. Then I had a phone call, and it was a very different phone call. I got a phone call on a Sunday asking if I'm free to talk for 10 minutes. And it was a company called Wipro, which is an Indian consultancy. And they had an opportunity to implement BIM for Ericsson, which is a telecommunications company. At that point, I thought to myself, Ericsson, didn't that close down 20 years ago? The last I heard was Sony Ericsson, and that was the last I've heard of them. Apparently, they serve a lot of the telecommunications and 5G networks in the UK, actually, majority of them. And then I was like, okay, this is quite intriguing and something that I haven't delved out. And based on my architecture background, it was a pushing boundary. It was very nice for me to try something else. But this client, different to most clients, is someone that exactly knew what they wanted. They wanted to set up their information requirements. They wanted up libraries. They wanted legal documentation sent out to all their contractors that they're going to deal with in the UK. And it was very, very straightforward. So within 6 months, they went from 2D information to a full library to a digital twin implemented on NVIDIA Omniverse. They had their own CDE built for them. A guy called Sean O'Keefe, Dr. Sean O'Keefe, built their CDE because they had a set of requirements clearly set out, writing exactly what they want, when they need it, and how. This is a atypical client. This is usually not what you have. Most times, a client you'd have doesn't know what they want. Their teams are not really in coherence. And that's usually where BIM actually falls through. So their facilities management team wouldn't be speaking to their BIM team. There wouldn't be a specialized information management. Most people think because you know BIM, you know information management, although they are very, very different roles, in my opinion. And then engineering teams, again, they're not involved very early on. So a typical project would be of the second kind, where you would early on start with having internal meetings with all the team leads, understanding what they have a problem with, understanding if they are willing to accept BIM, showing them how it can better their current implementation, and then move backwards from there. Go down to teams at a less seniority level and see what their problems are, and then help them through, and then take this information back to stakeholders to take decisions with. But yeah, so sometimes it's clients that exactly know what they want, and they are rare, very rare. But and then the rest it's usually you want to end up with the decision maker understanding that they're not spending money without a return. It's essentially at the end of the day an ROI. They could not care less if BIM is good for their business or mandatory or not. Is there a return on this investment? Yes. Can it clearly be shown? Yes. Okay, perfect. I'm willing to spend the money if I can see that return on investment. So you essentially gather enough evidence from the team to show the stakeholders how this impacts their team, and from a monetary perspective as well, how that helps them.
You already mentioned that there's a program in the UK that BIM has to be used in the public sector, at least.
Yes. So that was initially came in April 2016, and that was called BIM Level 2 mandate. That eventually failed. And then wasn't a real success. But in 2021, we have another document that came out called Transforming Infrastructure Performance by 2030. And that mandates the use of the UK BIM framework. The UK BIM framework advocates the use of ISO 19650. So ISO 19650 came about from it came about a couple of standards, but heavily influenced by British standards called BS 1192. And this shaped essentially how ISO 19650 is today as we know it. And if you look at it today, it's much more focused on information management. It's not really focused on being just a visual aid. It is primarily focused on structured data that is connected. So your alphanumeric data, essentially. And that's the core strength of BIM, I would say. It is breaking silos, so enabling collaboration, but also sharing structured information, as well as having immutability, which essentially means when you're sharing information now on something like a CDE, this information is never lost, never deleted. There's an audit trail. There's information that I can extract from my lessons learned, and I can always go back to find at any point if a project failed in a specific area, not overall, but I can exactly pinpoint what happened there.
And you already told me that that it's mandatory in the UK, or that they're planning to do a model for all public buildings.
Correct. So
I have one interesting question. Does it include the Buckingham Palace?
I wouldn't think so. No, so I think mostly TIP 2030 advocates for two things. So using UK BIM framework, but there's a national digital twin program as well. So, and it's a connected national digital twin, meaning that all buildings should be connected. Now, whether or not we're going to hit this target really relies on the implementation we do now for the next 5 years. And I think many organizations now moved away from the term BIM. So if you're aware of the UK BIM Alliance, which renamed themselves a couple of years ago called NEMA, now they've renamed again to the Information Management Initiative. So there's no BIM at all. So people can understand that the core principles of BIM are actually related more to information management. And if we can get this right, we can get a digital twin that is correct. Now, digital twin is a combination of good information management associated to the building elements or the asset elements. Whether you present this in 3D or not is actually not a big issue. You can have a 2D digital twin if you wanted to. Having a 3D is obviously much better because you have the spatial awareness of everything around you, but the core principles stay the same. Having robust alphanumeric information that is associated to the asset, and then you now end up including two things. You have your sensors and IoT data connected to these live linked essentially on your digital twin platform. And then there's another part where you simulate this information to get predictive analysis on mainly the operational part of the building, because that's where 80% of the money is being spent. So once a building is built, the rest of the money gets spent over the building lifetime. And that's where you really want to reduce your spending. Even if you don't say you want to reduce your spending, you want to reduce the amount taken to do maintenance, or you want to de-risk your project, essentially.
So that's a lot of work until 2030. And then comes your company as a software developer. You're developing software to doing, as I understand, part of the task automatically.
Yes. So in COVID, there was an opportunity. So we started the company during COVID. So perfect timing to start the company, and then COVID hits. But we had a bit of time as well to everyone's in the house to learn a lot of skills. I'm always interested in having software engineering in general to tackle issues that we face on a day-to-day basis, essentially. And we've done a lot of software. We started with Dynamo scripts and then Python scripts inside of Revit, but then we took that much further in the last couple of years of developing actual software. So one of the things we started doing is a fully automated conversion of native 2D drawings into 3D models. And we started with Revit. So that means we automate all of your walls, windows, doors, ceilings, pipes, cable trays, wires, structural. So we have columns, foundations, beams, trusses, everything fully automated from your 2D drawings. And it takes seconds. So one of our bigger tests is 50,000 square meters of a building. That takes about 1 minute and 20 seconds to be fully automated on all floor plans, essentially. And we're trying as best as possible to move industry forward. So we're saying by 2030, we want to achieve digital twins. While most of the drawings are 2D drawings or paper drawings. So we need to fix this first and then have something that represents the reality of this. Now, the reason we've done it is twofold. One is to make people's life a lot easier and automate this much faster, but also enabling users that don't have information that they can trust. Sometimes you have a floor plan that's quite old, let's say 20 years old, 30 years old. You're using that, and then you do a scan, so a point cloud scan, to verify that information. And that's where our second software comes in, which is automated point cloud into a 3D model. Now, this is much harder, a lot harder, I would say, than manipulating 2D information, because it's mainly lines. Whereas points, you'd need essentially density-based information, and then you'd need to have an awareness or segmentation of what these points with this density means. Is that a wall? Is that a door? So you end up doing some cleaning, some segmentation, and then you start building from there. For the CAD version, we're about 98% accurate. In terms of the point cloud, and this is a much harder problem, it's about 75 to 80%. And we're trying to get this much using machine learning. We're trying to have a pipeline by the end of the year to get this to a much more comfortable 90-95% accuracy.
So, but still, if you have 98, 90, 75%, that means there has to be some work to be done manually.
Absolutely.
And it's not like when you told me 1 minute, 20 seconds, that the engineer needs another 10 seconds to fix the rest, the remaining 10%. It needs 10 hours, right?
Yeah. So with the CAD version, the CAD version relies specifically on the input that you have. If the CAD is drawn relatively clean, the engineer will probably spend 5 to 10 minutes cleaning up anything else, not much more than that. If it's not, then you'll inherently have problems due to the CAD file itself. So the code doesn't assume information. It looks at lines, and let's say we have multiple walls next to each other. It looks at lines, takes a midpoint between these two lines, looks left and right of them, essentially, and say, okay, is this distance equal to the other distance? Okay, so this is a wall. Okay, I'll build up this wall. Now, let's say it has a junction, a T-junction. If the wall changes, it will change because it takes points along a longest line, essentially, and finds out the best. Now, sometimes you'll have people drawing different walls on different layers. It wouldn't pick it up automatically. You'd have to specify the layer. And the whole platform is built layer-based. And also sometimes it's just the CAD isn't clean. It's drawn a bit overdrawn or underdrawn. This we try to, as best as possible, take care of by doing something. So we see, okay, how many walls in this area have used the same wall thickness? Is this the correct wall, or is this randomly changed? Or has this wall thickness appeared anywhere else in the drawing? Because it might be a mistake simply because of a mistake in the original 2D drawing, but we try to check for that. So using the 2D version, usually you'll spend 5 to 10 minutes cleaning, especially since we have another tool, which is completely open source, that automates the dimensioning of these floor plans. So, and tagging of these floor plans. So I have all your dimensions and tag placed automatically. So you do the building, and then you'd have all your drawings also automated for you in terms of auto dimensioning and auto tagging of these. For the version with the point clouds, now the user at this point will spend a considerable amount of time. That sometimes, and that's why we don't want to release something like this now, because in a smaller floor plan, if I'm going to spend an hour correcting, might as well draw it from the beginning. I don't want to spend the time. You're essentially wasting my time rather than helping me out. But with the CAD, also we're looking at a specific subset of the community that would use this. These are people that want to use refurbishment or retrofit or have legacy buildings. These are the ones that we're looking at. New build, we're hoping people start in Revit automatically, although that's not usually the case. Some people still love using CAD in early design stages and then move in stage 2 or Reba stage 3. But yeah, we give you the opportunity to do that fairly quickly. And at this point, we support every single category in Revit. Now, apart from Revit, we're also doing this for IFC. If you don't want to deal with Revit at all, we're moving to IFC as well to automatically send this information to IFC. We've decoupled our code, so we're not relying on the Revit API except when you're creating information inside of Revit. Outside of Revit, you can use that with elsewhere. So, for example, IFC.
Let's have a little look into the future. You already mentioned that artificial intelligence could help or is helping. It's always, when it comes to pictures, graphical things, that's why NVIDIA is so important in this business.
Yeah.
It's very good for AI applications.
Yeah.
What do you think we will see in, let's say, 2 years, 5 years, 10 years coming up?
Well, you can start seeing it now, even from early on. So one of the things that is picking up quite a lot now, models, something called like Flux, which is image generation, are now not just being used for image generation. You can now pull this information into a software such as Rhino or Blender and get this 3D geometry out of the image as well. So you're not only relying on that you have an image, now you have a model of it as well, and you can section it and you can floor plans out of it. So that might quickly end up in early design stages. Now, it doesn't have to be fantastical in nature and looks like an alien spaceship. It can help out with the current design. It can also be helpful in you're giving it something that you're starting with and you're analyzing it. So where I see the next maybe 2 years is having AI embedded in a lot of the analysis work that we do for our buildings. That would be the first point. But that requires, unfortunately, a subset of people only to be using that information. Only people that have a bit of programming knowledge are going to be able to utilize that. People that don't are, maybe they're not going to be gatekept, but they're going to spend money to get the same result. Whereas companies that have people that do software engineering as well, I think there's going to be a lot of tying in between their architecture, structure, or MEP teams and their software engineering teams. I don't see the domain changing much in 5 years yet. That's my guess. I don't think it's going to change much. 5 years ago, when I got to use ChatGPT, well, it was called GPT-2 at the moment, before the chat version at all, I thought maybe 5 years architecture is going to go away. And I was completely incorrect. We're still here. And it seems like there's at least another 10 years until this actually fundamentally changes. But it's going to be a lot of apps built on top of this. And I see a lot of it being 3D first rather than 2D. And you'll see that with a lot of companies already. So you have a company like Koenig, for example, where you're building 3D and then you're getting your 2D information out of it rather than the opposite way around. And I feel like this is going to be the future, where you're building web-based and then you can add apps or build apps on top of that.
Final question. Would you recommend, let's say, a student studying engineering or architecture today to learn some coding as well?
Absolutely. I think that should be a mandatory course. I really think it should be a mandatory course at this point. Understanding the fundamentals of software engineering is a way of thinking, really. And it's very similar to how engineers think. It's usually problem solving. But understanding a simple language such as Python gets you into the door. And now with the amount of AI available and AI code assistance available, it doesn't necessarily mean that you need to do the coding, but you understand the fundamentals and you understand how to code check at a minimum. So you're able to utilize this information going forward, because you will get left behind if you don't.
Okay. Thanks a lot. I hope all the professors from universities listening to this episode, thinking about it, making it mandatory in their education. Ahmed, thanks a lot. It was a lot of fun talking to you, and thank you.
Thank you, Jörg. Cheers.
Okay. To the listeners, I hope you enjoyed this episode. As always, I'm open for criticism. Just contact me via email at info@cadtalk.de or send me a message over LinkedIn. And if you have any suggestions for future topics, just let me know. And don't forget now to click the follow or subscribe button in your podcast player so you won't miss the next episode. For today, I say goodbye. And I hope you all will listen again to CADTALK next month.